Dear students, greetings to all. In previous video, we have started isomerism and discussed chain isomerism, position isomerism and functional isomerism. Today, we are going to discuss the metamerism and tautomerism. First, metamerism. Metamerism, this type of isomerism arises where two alkyl groups which are attached to the polyvalent or divalent functional atom. For example, two different alkyl groups attached to the divalent functional group or polyvalent functional group. For example, we take that C4H10O. C4H10O. So here this molecular formula can be like this or like this. So this is the divalent atom. With this, to this, one side is the propyl group is there, another side is the methyl group is there. The same molecular formula here, there is a oxygen atom which is divalent, and one side ethyl group, another side also another ethyl group. So what is the difference between these two isomers? Means there is a difference between the alkyl groups which are attached to the divalent atom. So here one side methyl group, another side propyl group. So here both side you have the ethyl group. So these two are called as a metamers. So metamers can be arranged in the ethers or secondary amines. Secondary amines, you can see that same formula you can use it, C4H11N. C4H11N. So C4H11N, you can write it as a CH3NH CH2 CH2 CH3. Okay, and you also can write it as a CH3 CH2 NH CH2 CH3. Okay, these two are the metamers. Okay, or you can write it as a CH3 C double bond O CH2 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 CH3. You also can write it as a CH3 CH2 C double bond O CH2 CH2 6 CH3. Okay, so where you can get that different alkyl chains which are attached to the polyvalent or divalent functional group. Okay, so these are also called as a metamers. Okay, so this is the some of the examples which includes in the metamerism, and another one is that tautomerism. So tautomerism, this type of isomerism can be arranged where the same structure can exist in two functional groups, by interconverting. So for example, here we will take one ketone CH3 C double bond O CH3. So these also can be exist as a CH2 C double bond OH CH3. So this is the ketone and this is the enol. This is the enol. So keto enol always it is existed as a tautomers. It is existed as a tautomers. So you can define as a any molecule which can exist in two functional groups by interconverting. Such molecule can be treated as a tautomer. So ketone enol is the tautomers. Ketone enol is the tautomers. Okay, so here we have some confusion between the metamerism and position isomerism. What is metamerism? What is the difference between the metamerism versus position isomerism? Position isomerism. Position isomerism, what we explain about the position isomerism? Any substitution or functional group which is which is located in different positions in the carbon chain, such isomers are called as a position isomers. For example, we are talking about this CH3O CH2 CH3. Okay, another one is that CH2 CH2 CH3. Okay, this is the one. Another one is that CH3 CH2 O CH2 CH3. It is the second one. It is the second one. Third one, you can write it as a CH3 O CH3 CH CH3. This is the third one. Okay, so here 1 and 2, if you observe, so both are having the divalent atom with different alkyl groups. Here propyl group is there, here ethyl group is there. So 1 and 2 are metamers. 2 are metamers. And 1 and 3 if you observe, see here methyl group is there, here methyl group is there, and here this is the alkyl chain, this is the alkyl chain. So in the number of carbons in the alkyl chain there is no change. Okay, so what is changed here? The position of the oxygen is changed. So 1 and 3 are position isomers. Okay, so this is the this is about metamerism and tautomerism. What is the difference between metamerism and position isomerism? I hope you understood. If you understand, like, share, subscribe, so that it will reach to more people. We will see in the next video with more examples. Thank you.